Okay, the first time I did this, I made a little mistake, so we're going to do it again, and this time I'm going to correct the mistake that I made. It was just a little one. I substituted in the wrong variable. So we have a 10-foot ladder that leans against a vertical wall. The base of the ladder is pulled away from the wall at a constant rate of 2 feet per second. How fast is the ladder sliding down the wall when the base of the ladder is 6 feet from the wall? The first thing that I'm going to do, as I do in most related rates problems, is I'm going to draw a diagram. Now my hands, I am drawing terrible diagrams this morning. Let's see what we have here. So we have the 10-foot ladder, and then what's happening is it's sliding away from the wall, and the top is going to be sliding down the wall. Now, one thing about these related rates questions that we have to take into account here is when we have negative values. So if a rate is negative, that means that it's decreasing in size. If a rate is positive, that means that it's increasing in size. So as we see the ladder sliding away from the wall, well, if we label this as being x, we can tell that dx over dt is going to be a positive value. There we go. And there's a positive. Here, where we have that it's sliding down the wall, and if we label this as being y, we'll know that the dy over dt is going to be a negative value. That's just one of those facts that you want to keep into account, or that you want to take into account when you're working with these questions. Now, I'll label my ladder as being z, and we get that x squared plus y squared equals z squared, which is your classic Pythagorean identity. From here, we're going to take the derivative of this relationship. So I take the derivative of this with respect to time, d over dt, and that will give me 2x dx over dt plus 2y dy over dt equals 2z dz over dt. Now, when it comes time to start putting values in for these variables, something interesting happens. If we look, I have a 10-foot ladder. And one thing about this 10-foot ladder is that its size doesn't change. So at no point in time does the ladder ever change from being 10 feet. Well, what would that mean? That would mean that the dz over dt would have to equal 0 because that value is not changing. Subsequently, since it's a constant value, when I'm labeling my diagram off the bat, I could have very simply just labeled this as being 10. So I could have put 10 squared in at the beginning, and then taken the derivative of 10 squared, which would be 0, or I can substitute in that dz over dt, which is 0, which will give me 0 on that right-hand side. From there, I have that it's being pulled away from the wall. So since it's being pulled away from the wall, we know that this is the dx over dt. We also know that my x is going to be 6 at this point in time. Why couldn't I put that 6 in at the beginning? Because it's a changing value. We're looking at it at the moment right now after we've taken the derivative, so now I can substitute that value in. From there, we're one variable short of being able to solve this. So we have to solve this guy for y. What I'm going to do is I'm going to draw out my triangle, and I'm going to draw out the triangle as it would have been at the current state that we have. Whoops, that did not go well. Let's try that again. Become a teacher, they said. You'll learn how to draw triangles, they said. So we get that's labeled as 6, that's labeled as 10, and that's labeled as y. Using Pythagoras' theorem, we know that 10 squared minus 6 squared will equal y squared. 10 squared minus 6 squared is 64, so 64 equals y squared, or rather we get y equals 8. So going back over here, we have 2 multiplied by x, which is 6, multiplied by my dx over dt, which is 2, plus 2 multiplied by my y, which is 8, multiplied by my dy over dt, and this is going to equal 0. 2 times 6 is 12, times 2 is 24, plus 16 dy over dt equals 0. 16 dy over dt equals negative 24, or I get dy over dt equals negative 24 over 16. Now from here we can run the reduction wagon on this, and I could take this down to negative 12 all over 8. From there we could say that it equals negative 6 over 4, or we can just say that it equals negative 3 over 2. So going to my super cool other color, that didn't work. Going to my super cool other color, I circle my answer here, and we see that it's equal to negative 3 over 2.